Alright, so in this video we'd like to talk about the important temperature attributes of the fluid container. So before we begin with that, we'll first like to address some few things. Like we're going to tweak the attributes of the temperature, so that will obviously going to add up to the speed and the physics of the existing fluids. So to make it much more appealing and to make it much more sharper and richer in the quality, as we like to create the aggressiveness inside the fire, we like to tweak down the attribute of the solver quality, which is basically responsible for the overall quality of the fluids. So I would like to give the value to the 250 because the motion of the fields will also going to get affected. So that will going to make it adjust and will give us some more sharper results. The substeps we are leaving it to 2 only. We don't want to enhance it because our resolution will really going to be too high, approximately 250 or 300. So we would like to take down to the substeps to 2 only. And next, to accentuate the process a little bit more faster, here just for the demonstration purpose only, we would like to switch on the auto resize because our fluids will get speed up a little bit more faster. And if we would like to change the auto resize, we are using the auto resize to fasten up the fluids. So what we could do here is that we can just remove the boundaries to the none, to the y-axis minus y, and for the boundary z we could take it down to the z positive, because here if you can see in the positive section of the z-axis we don't want the fluids to go because the sample area is along this way. Alright, so there is no need to go towards the z positive section. So we like to keep the boundary to the z positive, and as we are moving forward, let's say we would like to explore the possibilities inside the temperature section of the fluid container. So first of all, I'd like to address the temperature scale, which is the overall multiplier for the attributes of the fluids and also defines the scope of the temperature voxels inside the fluid container grid. So we'd like to give the value to the 2, so which means that every attribute inside the temperature will going to get multiplied by the value 2. So now the buoyancy existing one will going to be counted as the 6, not to the 3. Alright, so the buoyancy here in this case will also represents the upthrust inside the force. So we'd like to give it the value of the 25 because we want the fluid to be very fast and aggressive. And then we like to move to the dissipation, which is the naturalistic behavior of the fluids or the gases to get dissipated, so fade away in the real world. So Maya tried to mimics the best possible way to dissolve, or you can say to fade out the fluids in the most realistic manner by dissipating them. So the dissipation attribute I like to give with the value of the 1. And in case of the diffusion, which is also responsible for promoting the black body effect inside the fluids. So now with the term black body, what I would like to say is that the black body is basically the zones of the color that produced during the time a substance undergoes the burning. You may could recall the colors of the lava, you may could say, because that contains the most hottest zone in the bottom part that shows with the white color, and then moving forward with the yellow, orange, brown, and then finally towards the black. So these attributes will really going to help us in dealing with that. Plus also we also need to be very careful because this attribute temperature is not only affecting the behavior of the fluids, it is also linked up directly here with the incandescence graph, which means the you can say the shading section of the fluid in which the incandescence, the attribute defines the self-illuminating property of the substance that emit light from itself. So fire being very, you can say, hot in the nature, as well as the source of the energy that produce the heat as well as the light, so obviously that is emitting the light from its own burning situations. So here the incandescence is also directly linked up with the temperature. So that means all these attributes are also responsible to promoting the you can say the good quality shading towards the fluids. So here you can say that if I'm gonna adjust the color white towards this, so this particular sections will going to provide us with the black body effect. So that would be possible if we use the appropriate value of the diffusions. What we're going to do is that it will going to, you can say, spread the temperature all across the neighboring voxels. That would helps in catching with the gradient effect of the color. So that is very important. But we also do need to be very careful with this attribute because we don't want to give a too high value of the diffusion, so it will gonna lose its aggressiveness. So what I can do is that the value 0.015 should be the best value for this reaction. Now let's move towards the turbulence, which is a very important section again. The turbulence and the noise, well, these two attributes are really very interesting, and people sometimes try to get confused with those attributes. So let me just clear out everything. Here the word turbulence is responsible towards the change inside the velocity sections of the fluid container. One don't need to be confused with the noise, because both sounds a little bit same. The noise and turbulence are kind of a disturbance, or you can say the randomness. So here turbulence is responsible for the randomness inside the velocity, and here noise is responsible for the change or the randomness inside the temperature voxels of the fluid container. So let's give the value of the 15 to the turbulence and 0.25 for the noise. All right. So with that, let's do one thing. Let's first of all change the resolution of the fluid only for the demonstration purpose, and let's just play the timeline and see what are we gonna have right now. So wow, here you can see that now the fluids are catching up with the colors, and as you can see, the colors are also being getting uh, you can see the gradient effect inside the colors. So this is happening because of the diffusion attribute of the fluids. All right. Also, we need to take care of the gravity field here. I have given the attribute 30 towards that, but I think so the attribute of 35 should be good, because we also want the fluid to get more shifted towards the Z negative sections. All right, so because the presence of the air, we're also going to bring some more aggressiveness inside the nature of the fire, so that is also very important. So I guess we are done almost with the values of the temperature, and in the next video we'll like to talk about the shading sections, and also going to talk about the opacity graph of the fluids. All right, so see you in the next video.